During the second week of May 2010, the latest news about the Deepwater Horizon blowout was that something called methane hydrates were interfering with efforts to capture leaking oil using a containment dome placed over the blowout site. Eventually, engineers were forced to abandon the containment dome idea because methane hydrates were blocking the flow of oil and also made the dome buoyant so that it floated away from the wellhead. Now, this was the first time that most people, including reporters, had ever heard of methane hydrates, and there was some confusion about just what these troublesome things actually are. Alternative descriptions for methane hydrates included deep sea ice crystals and methane ice, neither of which is completely accurate. Methane hydrates are a type of chemical compound known as a clathrate. Clathrates are chemical compounds in which a cage or lattice structure of one type of molecule encloses a second type of molecule. Clathrate hydrates are clathrates in which the cage structure is formed by water molecules. These clathrates were discovered in 1810 by Humphrey Davy, who found an ice-like material forming in mixtures of chlorine and water, even though the temperature of the mixture was above the normal freezing point of water. Gas hydrates are a type of clathrate in which water molecules form a cage-like structure around molecules of gas, such as methane, ethane, propane, butane, nitrogen, carbon dioxide, and hydrogen sulfide. Methane hydrates are the most abundant naturally occurring hydrates and are stable under conditions of low temperature and or high pressure. Under high pressure, such as found in the deep ocean environment, it's possible for methane hydrates to exist at temperatures above 0 degrees Celsius. The water molecules in methane hydrates form a crystalline solid, so it's accurate to say that the water is frozen and has formed ice. The methane molecule inside the ice cage is still a gas, though. Although methane hydrates are unfamiliar to many people, they are not new to scientists who study deep-sea ecosystems in the Gulf. Scientists are interested in methane hydrates for a variety of reasons, including that they are prominent features of some deep-sea ecosystems. They contain large amounts of natural gas that might be useful as an untapped source of energy. They have the potential to release large amounts of methane to the atmosphere, which could accelerate global warming due to the accumulation of greenhouse gases. If underwater methane hydrate deposits become unstable, they can trigger landslides that in turn may cause tsunamis. We have included one lesson about methane hydrates in the educational materials collection titled, "What's the Big Deal?" This lesson is targeted toward grades 9 through 12, but can be easily adapted for use at other grade levels. The lesson includes directions for building a model of a methane hydrate molecule, and this may be done either as a student activity or alternatively as a class demonstration. Other lessons about methane hydrates are referenced in the Other Relevant Lessons section of What's the Big Deal? We have also included ideas for some simple activities to reinforce concepts about basic geological processes involved in petroleum formation, and these are provided in Appendix 1.